So this is the second VCast for meteorology, and what we're going to do here is look at the processes that are required for the atmosphere to actually be warmed up. So first off, we're going to do some terminology here. Temperature and heat. First off, temperature. All right, temperature is just really describing how much thermal energy something has. Now, what is thermal energy? What is the difference between something that looks hot and something that's cold? We'll get to that here in just a few moments. But that's what you want to describe it as, how much thermal energy something has. And we can use a thermometer. It doesn't matter if it's Kelvin, Celsius, Fahrenheit. They all measure the amount of thermal energy. They just use different units. Heat, on the other hand. Heat is the actual transfer of thermal energy. All right? Because there's a difference in temperature. That's a big importance. All right, heat, some place that has lots of thermal energy is going to give away thermal energy to some place that doesn't, if they're in contact, because they have different different temperatures. If you want to view what thermal energy is, here's two little GIFs showing the example. Cold particles on the left, very cool, relaxed. They're not moving around a whole lot. Hot particles, on the other hand, are like those cats. They're just going nuts. There's a ton of energy there in their motion. So when you have like a fever, your particles in your body are vibrating more than if they were at a normal temperature. And again, heat always travels from a place that has high thermal energy to low thermal energy. So if we had to, thermal energy would be traveling from here over to here, all right, which would then cause those dancers to speed up, but also those cats to slow down. That could be done one of three ways. It could be done through radiation, conduction, convection. We're going to look at each one of these things in the next couple slides. So first off, radiation. Now, radiation, everyone thinks of danger, nuclear radiation. That's called ionizing radiation. And that's not exactly what we're getting into. When you think of radiation in this class, you want to think of radiation like this. Okay, if you see the sun, you're seeing radiation. You're being bathed in radiation. All right, radiation is just the transfer of energy by electromagnetic waves, aka light. All right, it could be your visible light. It could be UV. It could be infrared, X-ray, radio, microwave, gamma. Okay, those are just different forms of energy, and we'll get into what the difference of those are further down the line. But for now, just think of the visible light from the sun. That's radiation. Conduction, all right? Now, if you set a pot on a stove, okay, you know that pot is going to be hot, all right, because it's in contact with these burners that became very warm, okay? And those, in turn, since they were touching the pot, were very, very warm. And if you were to go touch that with your hands might get burned. And the way that thermal energy, is being transferred from the burner to the pot and potentially to your hand is by conduction. The transfer of thermal energy that occurs when molecules or particles are colliding. Think of, if you play pool and break, all right, the rack here, those balls aren't moving around very much. When something collides into it, it transfers energy to them and they start to move around, okay? That's what's happening when you touch something that's hot, all right? Thermal energy is being transferred by conduction. And the last one here is convection. Convection is a transfer of energy by the flow of heated substance. Okay, best thing to do is think of a lava lamp. All right, why are things rising and why are things sinking? Let's look at the mechanics behind a lava lamp. Well, there's a bulb at the bottom here that's heating it up by radiation and conduction. Right? But the wax at the bottom of this is being heated up and becomes warm. Okay, that lava becomes then less dense. And less dense lava wants to float to the top. All right. Now, at the other hand, when that stuff gets up to the top, it's hotter than the surrounding. Therefore, there's a temperature difference, so it gives off that thermal energy, becomes cooler. Cooler lava then becomes more dense than the surrounding liquid that was just heated up and begins to sink. So you get this rising of warm, giving off its energy, cooling of the dense to be reheated. This is a convection cycle. This is super important. That stuff we'll talk about more in further units about the mantle and what's going on inside the mantle to cause plate tectonics. All right, so let's actually get to the meat of the subject here. How in the world is the atmosphere of the Earth being warmed? Now, we've already looked at the geosphere and seen how thin of an atmosphere we actually have. And in the last unit, we even talked about, or the last VCast, we talked about the different layers of the atmosphere. The very first thing that we need to do in order to heat up the Earth's atmosphere is get the sun up. The sun is the source of all the energy in the atmosphere. And, all right, when that sun is shining, its radiation is traveling through space, traveling through the atmosphere, all right? And this is called insolation. All right, insolation is just the incoming solar radiation. Okay, it's stuck together. So insolation warms up our atmosphere, but it's not just straightforward as hits the atmosphere gets warm. If we actually break down, all right, let's say 100 units of energy from the sun are coming into us. All right, well, about 19% of it actually it gets absorbed directly from into the atmosphere by clouds or things like that. All right, roughly 50% is actually absorbed by the surface of the Earth. But again, then the remaining 36% is actually being reflected back out in something called Earth's albedo. All right, albedo is just how bright something is because of the light that it's giving off. We don't produce any light, neither does the moon. It's just reflecting. One of the reasons why the moon's so bright is because it has a very high albedo. All right, it reflects a ton of light that hits the surface of the moon. So not only are we getting light that's coming in, we also got to show some light coming back out. So this is step one. Radiation from the sun moving through the atmosphere, some getting reflected, but half of it, roughly, is being absorbed by the Earth's surface. All right, so let's zoom in closer to the Earth. We've got the Earth's surface here. We got the atmosphere. All right, some of that solar radiation is absorbed by the Earth. That becomes warm. And then, since it's a different temperature than the air immediately above it, all right, it can warm that bottom layer of the atmosphere by conduction, shown here by this red layer. Now, it's just the very bottom layer. That bottom layer is very dense compared to the rest of the atmosphere. So conduction can occur because of that. Conduction only happens when things are really closely packed together because, again, conduction is via collisions. All right, in step three, so you get this warm layer of the atmosphere here. Since it's warm, all right, it becomes less dense, and you may get these parcels of air, parcels just like a big pocket of air, rising up, okay, and begins to form a convection current, just like those lava lamps. That warm air rose. It's now surrounded by a bunch of cooler air. All right, it starts to give off its thermal energy, whether it's through conduction or through just radiation, all right, because it can radiate infrared energy, and that will warm up the surrounding atmosphere, but in turn cool those air parcels. And since those air parcels become cool, they will sink back down to be warmed up again, and the whole third step here kind of repeats itself in this convection cycle as long as the air is cool and the sun is shining and warming up the ground. So there was a lot there. I hope you just you kind of jot that part down, not just what's the wording up here, but also the words that I was saying. And that is how the atmosphere is warmed by the sun.